Hi, I'm David with Portrait Displays, and in this video, we're going to go through calibrating the Sony BVM-HX3110 with Calman. Let's get started. First, I'm going to launch Calman. While Calman's launching, let's go over the menu system on the Sony BVM-HX3110. Now, there's a significant amount within this monitor. We're going to focus on the menu items that are going to affect the calibration. Down here on the bottom, you have menu, back, and select and enter. These are going to be our primary controls for navigating the menu system. If I press menu, our first page is our user preset setting. This is going to hold the majority of the adjustments that we're using to optimize the image. Let's press select enter and go through some of this menu. You'll notice now we have something called channel number. I've noticed there are 30 channel memories here on the Sony BVM-HX3110, allowing me to set up to 30 different configurations, plenty for most demanding workflows. If we select the channel number is going to correspond to the settings below. As you notice I cycle through, you'll notice the settings changing for the calibration targets. We'll come back to channel 25. The next thing you'll notice is you're able to actually name the channel number. If you look at the top here, you'll see this is HD SDR right at the top because we've loaded that channel number. This allows me to name the channel something that corresponds to what my operator is going to recognize when they set up their Sony BVM-HX3110 for their session. As we come down, there's some settings for VBID Auto and SR Live Auto. These are really going to be dependent on your workflow, and I encourage you to test these with your equipment and how you like to work and set them accordingly. Next, we have RGB YCC range. Here, we can select limited, SDI full range, or come back to limited. For the purpose of this video, we'll stay in limited. Below that are EOTF. Let's cycle through and see what EOTFs are in the monitor. 2.6, CRT, 2.4 HDR, S-Log3, SMPTE ST2084, ITUR BT2100 HLG, S-Log3 Live HDR, and 2.2. Let's set this to 2.4 because I'd like to start with an SDR calibration targeting BT709 at 2.4 in the limited range. Next, we have our color space. Same thing here. Right now, the monitor is targeting ITUR BT2020. But since I just said that we want to target BT709, I'm going to change this until I get to the ITUR BT709 color space. Our transfer matrix will set to ITUR BT709 since we're working in 709. As we come down to color temp, you'll notice that's set to D65. I'm going to want to optimize my color temp for the purpose of this video, so I'm going to actually change this from D65 over to a user setting. Let's select user 1. Our chroma, brightness, contrast setting is currently at the default 1000/0400. If you select this, you're able to adjust those. We'll press back. User LUT, we're not going to use here today. And then there's some marker audio presets and advanced preset. We'll go through the advanced preset in another menu here in a moment, but note that we're set to preset 1. You can also copy a channel from one channel to another channel for a quick reference and then tweak. For example, if I wanted to copy BT709 from say channel 25 to channel 26 and then change the range from limited to full, I could do so without having to go through and reconfigure the entire memory. A very quick way to create additional channels with minor offsets such as that limited or full range. Let's press back and let's come down to user color temp. You'll notice here that we're in user color temp 1. That's because I just selected user color temp 1 in the channel setting menu. At this point, we have the ability to name our color temp if we'd like to, and we'd also have the ability to adjust our RGB gains and our RGB biases and copy from a different color temp. What I like about the ability to name my color temp is that I can set up different color temps for different targets. For example, if I was to target D65 CIE 1931, I could name it that. If I wanted to target DCI P3 white point, I could also name it that. That way I know what each color temperature I calibrated for is set up to without having to reference any notes. Another thing about the Sony BVM-HX3110 is the ability to change your signal when you're performing your calibration. Right now we're set to external, and we'll use our external pattern generator for the purpose of this video. However, if you didn't have an external pattern generator, You could change this to internal. Now, when I select the RGB gain, you'll notice a white box is put up by the internal generator inside the Sony BVM-HX3110. Our light meter is able to measure it, and we're able to make adjustments without the need for an external pattern generator. Let's back out, and let's come down to Advanced Preset. You may remember that this was in the channel setting right at the bottom. The Advanced Preset allows us to set up some of the idiosyncrasies regarding the input signal from SDI, such as the image division, signal format, how we want to process 1080 PSF content, but it also allows us to turn on the enhanced format for HDMI to fully utilize HDMI capability, or change that to the standard format so that we have more compatibility with legacy products. I'm going to leave this in the enhanced format. And now let's back out of the menu. I have the Sony BVM-HX3110 currently set up in channel 25 for a BT709 2.4 limited range calibration. But now we're going to want to go through the process to validate that optimization and perform the white balancing of the display so that we're hitting our target just as we expect. Let's come back to Calman, and let's come up to the top left Calman window, down to Open Workflow Template, and let's choose Calibration Broadcast Monitor. Here, we'll choose SDR calibration for BT709, and here, the first step is going to be to connect to your meter. You'll notice that today I'm using the Colorimetry Research CR300 spectroradiometer, along with the Colorimetry Research CR100 colorimeter. Now, I've already profiled the CR100 using the CR300 at the start of this video. If you're going to profile a meter for yourself and have any questions on how to do so, please click the link below and watch our meter profiling video. Let's come back to Calman. First, I'm going to search for my meters. I'm going to press Find Meter. I'm going to select my Colorimetry Research meters here. Let's choose the COM port. I'm going to choose COM port 4, and I'm going to press Search. Calman is now connected to the Colorimetry Research CR300. Let's press Find Meter, choose COM 7, and press Search. We've now connected to the Colorimetry Research CR100. At this point, I'm going to open my panel settings and adjust my CR100. I'm going to leave sync mode on auto for the purpose of this video. I'm going to come down to my meter profile and load the Sony BVM-HX3110 CR300 profile that I made earlier today. My next step is going to be to find my source. Today, I'm using the Virtual Forge pattern generator connected to an AJA IO 4K Plus running 12G SDI into the Sony BVM-HX3110. We're currently running 444 RGB, and one of the nice things about the Sony BVM-HX3110 is that if I come down here to the info page, it acts as a status menu. If I click on signal status, you'll notice we're running 3840 by 2160 at 2398, 444 RGB 10-bit. We can also come down, look at the channel that's currently active, how that's configured, and get information regarding the unit, such as the firmware, serial number, model number. Let's exit out of the menu and come back to Calman. For manufacturer, I'm going to choose SpectraCal, select my Virtual Forge. Calman auto-discovers the Virtual Forge on the network, and we'll press Connect. Now, I can open my settings panel and start to optimize the process for the Sony BVM-HX3110. Currently, my window size is set to 100%. I'm going to change this to 10%. I'll leave my pattern delay at 0.75 for now. And let's come back down to our third step here. The third step in Calman asks you to connect to display. Because the Sony BVM-HX3110 does not have DDC control integrated with Calman, we're going to skip this step and press Next. The next page of this workflow asks us to set our calibration targets. Because my goal is to calibrate the display to BT709 limited range or narrow range with a 2.4 EOTF, I'm going to set those targets here. You'll notice the white point's already at D65, the color space is at Rec 709 sRGB, and the EOTF is at ITU BT1886. Let's change the EOTF to a power function because that's what we've set inside the display, and we'll set this to 2.4. Let's press Next. And now we're prompted with the pre-calibration capture on our workflow. I'm going to come down to the bottom right-hand corner, select Read Series, and Calman's going to go through the process of putting up a pattern, taking a reading, and plotting the data so we have a better understanding of the pre-calibration results before we start really fine-tuning the display. Okay, Calman has completed our pre-calibration capture. If we look at our RGB balance here, we'll notice that we're going plus blue. Our EOTF is tracking very close to that 2.4. Remember, we set up 2.4 when we were going through the configuration process. Our maximum luminance is a little low at 92 nits, where we want to have 100 nits to hit the BT709 target. The maximum delta E2000 is currently at 6.7 with an average of 4. And our colorimetry has that maximum error of 6.7. Once again, that looks like it's coming from the white point here because we have that blue shift in our white point with an average of 1.9. If we look at the chromaticity diagram here, the CIE 1976, we can see that the color points are hitting very close to their targets here, letting us know that we are most likely in a BT709 color space on the monitor. Let's go and fine tune this. I'm going to come over here to the left and select white balance. Here, I'm going to select 100%. And I'm going to hit continuous read in the bottom right-hand corner. Now Calman's going to put up this pattern, take a reading, and plot the data. We're going to have our RGB balance chart here that's going to show us the amount of red, green, or blue, and then we're going to have the X and Y CIE 1931 in the bottom left-hand corner where we can use the X and Y coordinates should you want to work that way. Let's press menu, hit select in the user preset setting, scroll down to user color temp, and let's come over to RGB gain. At this point, if I want to use the RGB balance, you'll see we want to take down blue to get it closer. So I'm going to come over here to my dials, and I'm going to take the blue dial, which is your brightness, and decrease that. As we watch the RGB balance chart, you'll see the blue is coming down closer to the red and the green. And if we look at our X and Y, you'll notice the 3108, 3213 is now moving closer to that 3127, 3290 D65 target. Okay, we've got a 3127, 3247. So now I want to adjust the Y-axis and I want to bring up that green. So I'm going to move over to green and let's increase that green until we can get to that 3290 Y target for D65. Okay, we've overshot just a hair. So here we are at 3125, 3293. But we're at about 95 candelas per meter squared, or nits, and my target is 100. So now what I'm going to do is I'm going to increase the luminance on the panel so that I'm able to hit that 100 nits. You'll notice we have red, green, blue, and then contrast is RGB. I'm going to choose the contrast here and increase the luminance. You'll see R, G, and B are increasing. We're not really shifting that white point, but we are bringing up that luminance Y, with our target being 100. All right. There's one more thing you should be very careful of when you're calibrating this display. When you're in the white balance control, if you do press back or menu, you're going to lose the adjustments you just made. You're going to want to hit the select enter button to save those adjustments. Another thing you might have just noticed is that we had the display set to the internal pattern generator. So we were white balancing on that internal patch, but let's come down to the signal and choose the external moving forward. I'm going to press menu to exit. I'm going to stop my read. And now that we've got our white point dialed into D65, let's see how we're tracking the entire grayscale. Let's come over to the multi-point grayscale here on the left, select it, and let's now hit the read series in the bottom right. What this is going to do is go through the entire grayscale from black to white, so we have a better idea of how that RGB balance is tracking throughout the entire range. Okay, the multi-point grayscale has completed. If we look at our RGB balance chart, you'll see the red, green, and blue is really, really tight throughout the entire range. If we look at our delta E2000 numbers, our maximum error is a 0.3 with an average of 0.2. And if we come down to our data points, our data grid here, we can see at 100%, we're getting a 3124, 3291 at 100 nits. So we're tracking a really accurate grayscale throughout the entire range, hitting that 2.4 EOTF and hitting our 100 nit target. Next, I'd like to come over to the left side of the menu here and choose the color space setting. What this is going to do is measure the edge of the gamut to ensure that we're hitting the BT709 color space to let us know if we might have changed something during the calibration process or got something off from where we were with that pre-calibration. We were already really close, and I don't think we made any changes on the monitor to change our color space, so I expect these to track really, really nicely. Okay, as we can see, we are hitting these BT709 targets. Our max Delta E2000 is a 0.8 with an average of 0.4. But I want to get a little more granular here. I'd really like to know how well the color space is tracking inside of the color gamut. That's where your flesh tones are going to live, and most of the colors you're going to see in your content are going to live. So let's come over to the left side and choose our additional validation here. Let's go down to the color checker and press Read Series. The color checker is not only going to take measurements at the edge of the gamut, but also inside the gamut. That way we have a better idea of how the color gamut mapping is happening within the display. Let's take a look at the results. As we can see, the measurements are pretty much hitting the target squares here on the CIE 1976 chart. And if we come down to our Delta E2000, we'll notice we have an average error of 0.4 with a max of 0.9. Excellent results. It is tracking as we would expect. We can also go to the next page here if we come over to saturation sweeps and perform a saturation sweep measurement. This will give us a little more of an idea of how the primary and secondary colors are tracking as well. Okay, the saturation sweeps have completed, and as we can see, the measurements are hitting their target squares here on the CIE 1976 chart. And if we come down, we'll notice that we have a Delta E2000 with a max of 0.8 and an average of 0.4. Once again, excellent results. We are hitting our BT709 2.4. Now, if we want to, we can do a post-calibration capture and compare those results to our pre-calibration readings. Let's click on the post-calibration capture here on the left-hand side, and let's come down to the right and hit Read Series. All right, as we can see, our post-calibration capture has completed. Our RGB balance is tracking really tight. Again, that max 0.4, average 0.3, 100 nits here in the bottom right. And our Delta E2000 on chromaticity has a max of 0.8 with an average of 0.4. If we come back over here and we select our pre-cal capture, we'll notice our Delta E2000 for the grayscale was at a 6.7 and the average on the chromaticity 1.9. Okay, so we now have our Sony BVM-HX3110 calibrated to BT709 with a D65 white point, limited range with a 2.4 EOTF. Now let's make it so that our operator has ease of use when using the monitor. We're going to press Menu, select the user preset setting, come over to Channel. Instead of having to know that Channel 25 is set up for this particular target, we're going to come down to the name. Here, I can change the name of the channel to anything I want. I'm going to set the name to something that makes sense to an operator so they understand exactly how the monitor is configured. Okay, and now we've named User Color Type 1 D65 CIE 1931. So anyone using this monitor will understand that this was calibrated using the color matching function CIE 1931 set to D65 in the User 1 mode. We've now set up the SDR BT709 2.4 limited range on the Sony BVM-HX3110. But what about HDR? Let's come back to Calman. We'll choose the welcome page, select HDR calibration. Now I don't have to find my meter again. I still have my colorimetry research CR100 set up with its meter profile for the Sony BVM-HX3110. I'm also already connected to my source. So let's hit next. And at this point, we're being asked once again to set our calibration targets. For the purpose of this video, we're going to use the white point of D65, the color space at BT2020, and the EOTF for ST2084 PQ, and we'll work in limited range. Let's get started with configuring the Sony BVM-HX3110 for this particular mode. Press Menu. We'll select our channel setting. Now we just set up channel 25 for BT709 2.4 limited. Let's select another channel, hit select, change it to 26. Now we've come over to channel 26. Remember I mentioned you can copy settings? We can come down here and we can copy from channel 25 if we'd like. Now of course we're not going to use this because this is going to be a different target, but we've now copied 25, 26. So now I actually have the same name and I can modify that later as needed. Let's come on down to the EOTF and let's change that to our target of SMPTE ST2084. Our color space now is going to become BT2020. We're going to change our transfer matrix to BT2020 since we're now working in the BT2020 color space. And if we are using YCBCR, we should be outputting content encoded in the 2020 transfer matrix. And now I have an option. I can either use color temp user 1 which may translate to the higher nit mode. But often I like to calibrate a separate color temperature when putting the display into these higher nit modes so I can really fine tune based on the thermal characteristics as we go into high dynamic range. So I'm going to change color temperature to user 2. We'll keep our chroma, brightness, and contrast at their defaults, 1000-0400. Keep our user LUT off. And we are in advanced preset 1. Now let's press back again, and come down to the system settings. You'll now notice we have an adjustment called peak luminance config. Now the Sony BVM-HX3110 has a couple options here. They're all geared around how you'd like your monitor to perform. With peak luminance config set to off, the Sony BVM-HX3110 will do 1000 nits regardless of the average picture level. If we change this to 2x/LP, the display will hit 2000 nits peak on a window pattern and 5000 nits on a full field. The fans stay in a lower operating mode, keeping it a little quieter if you're operating really closely to the monitor. If we change into our next mode, we have a 2x multiplier. We'll now do 2000 nits in a window pattern, but we'll also hit 1000 nits with a full field. The fans will kick up a little bit, you'll have a little more noise, but to me, it hasn't been that much of a bother. Let's go to the next mode. You'll notice we have a peak luminance config 4x. In this mode, the display will hit 4000 nits on a window pattern and 1000 nits full field. The APL, or average picture level modulation, is going to get a little more aggressive here. As the APL goes up, the luminance is going to come down, but you'll still be able to hit that 4000 nits with those specular highlights. For the purpose of this calibration, let's turn peak luminance off. I'm going to back out of the menu, and let's come back to Calman. We've got our target set to D65, Rec 2020, ST28-4. Let's come over to our pre-cal capture. I'm going to right-click on History 1 to clear our tab data from our previous SDR calibration. And let's hit the read series in the bottom right. Okay, so the pre-calibration capture is completed, and as we can see, we're going a little bit red in the RGB balance, hitting that a little bit warmer than we'd like for that D65. Our maximum error here is a delta E2000 of 2.8 with an average of 1.4. Our delta E2000 on the chromaticity has a max of 1.9 with an average of 1.3. We are hitting these targets. We did set up that BT709 color space in the display, so we are tracking as we would expect. And if we come down here, we're getting 921 nits, so we might be a little bit low. And if we look at this EOTF chart here, we can see the gray is just below the yellow target line, so we may be tracking PQ a little bit low here. Let's come over to the left-hand panel, and let's come over to white balance. Once again, I'm going to choose 100, and we'll come over and hit the read continuous. While Calman's hitting read continuous, it's putting up the white pattern, it's taking a reading. We're going to press menu, come over to user preset setting, scroll down to user color temp. We're in user color temp 2, and now we can choose our RGB gain. And let's see what we need. It looks like we are a little high on the red on the RGB balance chart, so we'll bring that down just a little bit. And now let's bring that blue down. Looks like we're a little high in the blue. And we're currently measuring 3127, 3290. But we are at about 950 nits, so we're a little low on our nits. Remember, we want to hit the select button here to save. Now let's back out, hitting the menu. We'll press stop inside of Calman. And let's jump over to the multi-point grayscale here on the left. I'm going to put up black for just a moment because we are heating the panel with that bright white on the screen. And let's hit read series. Now it's important to measure the white balance in EOTF when we're measuring in SMPTE ST28-4 and PQ. Not only do we want to know how our white balance is performing throughout the range, but we also want to know how well we're tracking PQ. Remember, it's an absolute format, so it's really a bit for nit. We want to make sure that each level is hitting the luminance target level. If there are going to be any errors, I like to move those errors up to the top part of the curve, or the lighter portion, because most of the content's going to live in the lower part of the PQ curve. We're looking at most of our content being at 200 nits or under, maybe 300 nits or under. As we start going up into those higher luminance levels, you're going to find there's less and less image content that's going to live there. Let's take a look at how we're tracking. Our RGB balance chart looks very good. Our delta E2000 has a max error of 2.2. I'm not super happy about that at the moment. We are tracking PQ, but it does look like we're still under tracking that curve, and we're at about 916 nits. But we are tracking 3127, 3289 at 100. Let's take a look at 50 on our data. If we look at 50, we're at 3129, 3287, 85 candelas per meter squared or nits, and we should be targeting here 94.3. So we are a little under tracking. So what I'm going to do is I'm going to put up 50%, come over to the right here and hit read continuous, and let's now press menu, select user preset setting, come down to user color temp, select RGB gain, and now what we're going to do is we're going to adjust RGB by using the contrast control. I'm going to push this up, and as you can see, as I turn this knob to the right, we're increasing RGB, effectively increasing luminance on the panel. As I look at 50 here in Calman, I'm going to try to get that up to about 94 nits. Okay, so we're at 94.0, our target's 94.378. Maybe to go just a couple more. Remember, there is going to be some fluctuation in the meter and the repeatability and the stability of the system. Not to mention, we also have some very bright lights in the room shining to make this video. That could also be contaminating the readings a little bit. We'll press select enter. We'll exit the menu. Let's come back over to Calman, press stop, and bring it back down to black. And then let's take another sweep here by hitting read series. Okay, as you can see, our multi-point grayscale has now finished again, and you'll notice that our max delta E2000 now has come down to 0.7 with an average of 0.3. We're still tracking that grayscale really nicely throughout this RGB balance chart, and our EOTF curve is tracking a lot more closely to that yellow target line on both our EOTF chart and our luminance chart. We're hitting 1011 nits, and if we come over to the left here, we can change delta E2000 to the delta ITP metric, which is typically used in HDR. We're still getting a max delta ITP of 0.9 with an average of 0.5, so we're still under a max delta ITP of 1 throughout the entire EOTF grayscale tracking here. Excellent results. Now, I might be able to spend a little bit more time fine-tuning this and getting that down just a little bit, but we're already in some of the best results you'll see from reference grade monitors that are out there. Let's come back to Calman and choose Color Checker under Additional Validation. I'm going to right-click on History 1 and hit Clear Tab Data. Now let's hit Read Series. Calman's now going to put up a pattern, take a reading, and plot the data. Remember, there aren't really any commercial monitors available today that do full BT 2020, especially up to 10,000 nits in high dynamic range, as we're measuring right now. But we do want to make sure that within the display's capability, we're tracking colorimetry as expected per our target. The color checker is finished, and as you might notice, we're not hitting BT 2020 100%. Remember, the display's specifications don't specify that it will hit it 100%, and at the time of this video, I'm not aware of any commercially available monitors that are going to hit BT 2020 100%. Notice that the inner colors, though, are hitting their targets as we would expect from this monitor. You'll notice the delta ITP is extremely low until we get up to those points with red, green, blue, cyan, magenta, yellow, where we're not going to be able to hit 100%. Therefore, the error gets larger. If we switch over to delta E2000, the errors come down based on the metric, and we have a max 3.1, again with the majority of that error where the monitor can simply not hit BT 2020. Let's switch back to delta ITP, and now let's come over to saturation sweeps. Now let's come up to History 1, right-click, hit Clear Tab Data, press OK, and hit Read Series in the bottom right-hand corner. You'll notice we're measuring P3D65 inside the BT 2020 container because it's a common workflow for both the production and post-production communities. Our saturation sweeps have completed. If you take a look at the CIE 1976 chart here on the right, you'll notice our measurements are hitting their targets. We also have very low delta EITP numbers, and if we come over here and change it to delta E2000, we have even lower given that metric. Let's go over to the post-cal capture page. I'm going to right-click History 1 and hit Clear Tab Data. Press OK, and then hit Read Series in the bottom right so that we have the post-calibration capture to compare to our pre-calibration. Okay, our post-calibration capture is completed. Our RGB balance is extremely tight. We're tracking that EOTF curve here on the right. We're hitting 1006 nits. Our delta E2000 max on our white balance is 0.7, and our delta E2000 chromaticity has a max of 0.5 with an average of 0.3 and you can see we're hitting our targets on the CIE 1976. Now, if we come back over to the left side here and we click on pre-cal capture, we'll notice we had that larger max error at 2.8 with a max error on chromaticity of 1.9. We've improved on that. We've tightened up our target points on the CIE diagram, and we've improved our luminance as well as our PQ EOTF tracking. Now that we've finished the calibration of BT 2020 HDR limited range on the Sony BVM-HX3110, I'd like to do the same thing for my operator where I name my channel. So I'm going to come over here and I'm going to change my channel name from BT 70924 limited to BT 2020 PQ limited. As you can see, BT 2020 PQ limited. And now if I want to get really detailed with this, I can come down to user color temp, and I'm going to rename this D65 CIE 1931H. That way I know it was made in HDR. You can of course use the naming that you prefer for your workflow. And there you have it. We've now walked through the calibration process for the Sony BVM-HX3110 using Calman for both SDR and HDR. We hope you enjoyed the video. We'll see you on the next one.